Welcome to a new episode of Automotive Storytelling. We are here at the core of the IOM TT, one of the most incredible races there is on Earth, to talk about connectivity. Because we know how connectivity is at the core of the automotive industry today. Whether it's software-defined vehicle, autonomous driving, OTA updates, connectivity is a must for automakers. But the problem is that managing connectivity can be a massive challenge. Whether adapting to local regulations, adapting to changing environment, new technologies, and much more. So make sure to stay tuned until the very end of this episode, because we're gonna go under the hood of connectivity like you have never seen before. What you have behind me is a track where the riders can go up to 200 miles per hour. So at those speeds, you need to react in an instant. You can't think.
For pretty much as long as the racing's been happening, there's been people out around the course to ensure the safety.
So how do you do that around a track of 37 miles? Well, since the very beginning of this race, the marshals have been forming a network all around the track.
Obviously, things evolve in terms of where those people are positioned, the way we communicate. You know, we have the radios that we can communicate with each other now that, of course, they didn't always have back in the day. So I'm not entirely sure how they did it then, whether they had some of they used to have to run up and down between the points.
And it's a network that is distributed, real-time, and fault-tolerant. And those are the exact same characteristics of any network around the world. So this is where the analogy is very powerful, is that what the marshals have invented here about 100 years ago is actually a perfect analogy of what every network is today. Watch what happens as the bike passes. The marshals here tracks it, and the moment it's gone, the next one down course already has it.
People talk about line of sight, and for a lot of people they used to assume that that meant the marshal could see the next marshal point. That's not the case. It's actually about where, as the riders are coming through at the speeds they travel, they will always be able to see a marshal.
In a network that is handover, your phone passing from one tower to the next as you move without the call dropping.
There isn't really a set distance between them. It all depends on whereabouts they are on the course, and obviously whether there's corners or straights or anything like that. It's ultimately about making sure that the riders are able to see a marshal.
Now, the marshal at this corner doesn't phone headquarters to ask what to do. There is no time for that.
And we get others who are very much, they go, that's their spot, that's where they go year on year. So of course, if they're going somewhere regularly, they know, like, changes of direction of the wind, the sun dazzle. You know, we have a flag to warn of sun dazzle. That's at certain points over on the west side of the course. So that obviously the longer they spend there and the more time they marshal, they get to know the things that they're looking out for and the things that might affect the safety of the racing.
The decision gets made right here, where it matters. That is edge intelligence. You push the thinking out to the edge of the network to where the action is, because the center is too far away and too slow. And look closely. There is never just one marshal at a corner. There are at least two. Because if one goes down, an injury, a radio failure, a moment's distraction, the corner still has to be covered.
You need at least 4 people to carry a stretcher. You need a certain number of people to be able to move a bike. So we will always man them according to what the potential for that area is.
That is redundancy. It's the difference between a system that works on a good day and one you can trust with a life at 180 miles an hour. It's how you reach 99.99%, not by hoping nothing breaks, but by designing for the moment something does.
They don't have any contact. Once they're out on the road, it's just them, the bike inside the helmet. So we're the only way that we can communicate any messages to them.
Handover, edge intelligence, redundancy. A distributed network that is real-time and built to survive its own failures. And every bit of it runs on 600 people in orange, standing on a road on one island, 2 weeks a year. Hold that picture, because the rest of the world is about to need exactly the same network everywhere, all the time, and it cannot use volunteers. Hey Chris, very nice to meet you, because I'm not meeting anyone. I'm meeting the guy who has been launching 3G for the first time in Europe. So tell us about this, because that's an incredible story.
Well, that's where the grey hairs came from, of course. No, it was a really, probably the most exciting thing I've done in my career. Well, my boss says to me, "Can you go see if you can get a license to launch a 3G network? Because if you can, this will be brilliant for us. We'll get lots of learning. So yeah, go and try and get a license." And he made it sound quite easy. So I put in writing, paid 19 pence for a stamp, posted it to the regulator, and literally a week later, the license came back in the post. We were in a race with Docomo. Yeah, we both had the same supplier.
Oh yeah.
And there was quite a lot of press interest to this. And it was one of the headlines, and I've still got it in my cuttings at home, was Kippers v Sushi. Because people knew we were in the race. But so we were the first in Europe. There is no killer application. It's just giving you fast access to the internet.
Yeah.
And then it's down to each individual. What do you want to use it for? Do you want to use it for buying your stocks and shares? Do you want to use it for research? Do you want to use it for video calls home? So so that was really the main insight, that actually to get high-speed access to internet was a game changer. I think the best thing about the island is it's small and friendly. So when going back to the 3G trial, I only had 200 handsets, a real handset in the hands of real people, and that's what they use it for. So that when we launch in the big market, we can focus on that. I've got some incredible feedback from people. Mike was going to take a year off for travel around the world, and then lockdown happened. So we had a coffee just before we all had to go and lock our stuff away. And most people watch movies or read or whatever. Mike decided he wanted to program and code, and he felt that with modern coding techniques, he could put all of that into software.
Okay.
Which was, again, an incredibly big ask. And I actually remember saying to him, like, "You're the smartest guy I know, Mike, but I don't think it's possible." There's 2 or 3 technical barriers which you just can't solve. And actually, also, why haven't Nokia and Ericsson done it? But anyway, that was obviously the motivator to Mike. So anyway, he locks himself away in his back cave for a year. He came out at the end of lockdown, and he'd actually cracked it.
So I did what I think everybody should do in lockdown, and build a mobile network. I mean, isn't that a natural thing to spend your time doing?
And this is essentially where you started to think about software-defined connectivity.
But customers like that, the day before, they were probably in AWS, logging into AWS at 2 o'clock in the morning, halfway through their pizza, spinning up a VC, a virtual network, configuring exactly how they want it at their fingertips and paying for it on a consumption basis. But that just didn't work with mobile operators. Everything from a mobile operators, it was talked about in terms of at least months, not hours, let alone any quicker than that, and hundreds of thousands of pounds to get started. There was no democratization in mobile in the same way as there was in hyperscalers. So that's where I thought, if it's possible to deliver a mobile network in that way, it would solve a lot of the problems I was hearing about from customers day by day, that the mobile industry just wasn't well placed to serve.
If you would explain to somebody who doesn't know anything about networks, what is the before and after of software-defined connectivity?
In the old world, you got a SIM card from a mobile network operator, and it puts you on the internet. You put that SIM card in a device, and that device is then on the internet. And you can layer various services on top of that interconnection, like VPNs and firewalls and things, to try and limit what it can do. But in the new world, it's a smart pipe. If you're going to put those SIM cards in fire alarms, the requirements of that connectivity are very different to what SIM cards you might put in a vehicle tracker. But in the old world, it's just a SIM card's a SIM card, very vanilla, and you had to wrap a lot of complicated services around it to make it, to tailor it for the application. SIM card and a fire alarm, it's not going to move. It's unlikely to move. It's bolted to the wall somewhere, but it's really important it connects to the network. And if the network it normally connects to is down, it's really important it connects to a different network, irrespective of the cost. It's a real life-critical application. But a vehicle tracker, you put in your truck and it travels around Europe, you might want to pick the preferred network in each country. You need to know where that SIM is at any time. You want to be able to control how much data it passes. It's a totally different set of requirements. So our approach, by building the core network from the ground up from first principles with that in mind, allows each of those slices to be configured in the same way as you might create your Amazon VPC differently or your local area network in your office differently.
Think back to those 600 marshals. Handover, edge intelligence, redundancy, a network you can trust at 180 miles per hour. Now put that same demand on every connected car on Earth. A modern vehicle like this needs exactly what a TT rider needs. A connection that follows it everywhere it goes, that makes decisions locally in milliseconds, that never fully drops even when part of the network fails. The same three principles. But not for one road, for every road. Not for 2 weeks, for the entire life of the vehicle. Not in one country. In every market, the car is sold. You can't do that with 600 volunteers in orange jackets. You can't put a marshal in every corner of the road. So you need to do this in silicon. The network the marshals run on instinct. Connected vehicles needed written in software, available everywhere, all at once. And that, doing in software what 600 marshals do on instinct, is actually one of the most complex challenges in automotive connectivity today. This is where the industry is stuck. So let's talk about why. Let's say take a car. We take a car that is in Australia. Mm-hmm. Can you walk us through what a car would do from a connectivity or data perspective without your solution and with your solution?
Sure. So the car, I mean, obviously different generations of car behave differently, but in terms of, let's just take a standard use case. So a car what chooses to connect to the network, it would, without our solution, it would, if it was a roaming solution, it would connect to one of the preferred networks, one of the allowed networks, and then it would establish its data session. Now that data session wouldn't be establishing in country, even though it's connecting to the local radio access network. That data session actually goes all the way back to the home operator. So that home operator could be, we know examples of Hong Kong, Singapore, for example. Sometimes European mobile network operators are used to roam in Australia. So that means the data would come all the way back to Europe just to go back to Australia. So you end up, it's called tromboning, but it's like a loop for the data, which is very inefficient. You can be looking at hundreds and hundreds of milliseconds, sometimes 1,000 milliseconds. With our Edge product is the ability to keep the same subscriber that's in the car today and has always been in the car without the need to do SIM swapping or over-the-air SIM swapping, but just to be able to repoint what's called the APN, the access point name, towards our solution. You can do that within the network or on the device if you want to. Repoint that to our Edge solution, meaning that existing estates out in the field can actually be repointed into country now. So if there are OEMs out there, which we know there are, who are having these connectivity challenges around latency, you can actually retrofit this capability without changing anything on the car.
The second use case we have been talking about is Brazil. What would be the current challenges that an OEM would face in a country like Brazil versus what they would achieve with your solution?
Right, so I mean, there's different OEMs across the world going into Brazil that are in Brazil. And they're faced with one common problem, which you've already mentioned, which is the data sovereignty, regulation and compliance side of things. Latency is also a factor there as well, but it's one of the unique properties of Brazil. This is a small subset of countries that have very, very tight regulation and operating criteria, but that's increasing across the globe. We're seeing countries become stricter and stricter from a regulatory perspective. Yeah. So from an OEM's viewpoint, you're shipping cars, let's say from Germany or from Japan or wherever it might be. It may typically won't be a roaming solution in Brazil. So they'll work with a MNO or connectivity provider that has their own IMSI in Brazil. But that connectivity provider typically today would route all of that traffic, typically in a solution, route that back to their wherever they're based. That doesn't work in Brazil because the traffic has to stay in country. Yeah. There's also other side benefits like content delivery networks being optimized, so you get Brazilian content and those sort of things in that use case. Because again, with our solution, we have, and Brazil's an example of where we have, as is Australia, we have our Edge sites deployed today, where the connectivity and our solution is already in country. So we have a number of customers in Brazil now, and they're all using our edge site to keep their data. So again, if you look from the perspective of an SDV, then the car is connecting via whatever means it's connecting, typically a Brazilian registered IMSI for regulatory reasons. And that traffic is related to our packet gateway. So they use specific APNs. Again, it's the edge solution of ours to keep that data in country, so that the data traffic doesn't leave the country.
The third use case we've been talking about is more of a multinational approach. So for instance, an OEM could be a Chinese OEM, for instance, who is coming to Europe and needs to address multiple countries, because Europe is not really one territory, multiple countries, multiple regulations, and so on. So what is the major challenge for them?
So, well, if you think about a global deployment, so obviously we have cars manufactured by certain nations across the world. Coming into Europe is probably one of the easier ones. It's not easy, but it's easier. Getting stricter as well. But for example, some of our customers in this space will land and use just European-based locations. So Amsterdam, Frankfurt, Dublin, for example, EU-based, and then UK obviously is something we do very well. So that's, typically in Europe, there's an acceptance in automotive that it's okay that the packet gateway termination side of things, the data side of things, terminates within Europe as a region with geo-resilience. I mean, there's lots of factors to this, wanting to have local resilience within a country, but also having geographic resilience should a particular country struggle with its connectivity, so cars stay connected. But look further afield, so there are OEMs out there, of course, that have, the examples we've got are Europe, Australia, Singapore, South Africa and Brazil, and then Americas. That's a very deliberate deployment model from our perspective, because they are specific areas where automotives look to deploy. We also have some private dedicated deployments which aren't on pins on our map, so to speak. They're specifically MNOs or MVNOs locations. But those are the key locations that people want to deploy to.
So let's imagine that an OEM that is listening to us decides to use one of your partners that uses your technology, right? And something that he was not doing before. What would that enable this OEM to do that would be impossible today?
Well, I think any single one of these things is probably possible with the right partner, but it's a combination of the things, right? So, I mean, people often get cross to me, people like you often get cross to me when I talk about the speed in which we can do things.
Yeah.
But actually, I think this is critical. So we had a partner about 2 months ago actually come to us and say, we want to just test your edge solution. They were using our core solution. We want to use your edge solution for this particular customer. It's actually a Chinese customer. But we just want to bring all of these subscribers. It was just I think 500,000 subscribers. Okay, well, you can test it first. The test typically would take, to set up this distributed network would take, I don't know, about 6 months, maybe 9 months.
Okay.
We happened to have an edge site exactly where they wanted it. It took us 4 minutes to set
4
up.
minutes?
Yeah, 4 minutes.
Wow.
But that's because we already had our cloud, our connectivity cloud there deployed, and the ability just to set up an APN, as it's called, and route the traffic via them using our OCS, all of our stuff, was really that quick. Now, the actual solution we've already deployed, so that was only 2 months ago, we've now gone live with the solution, took 4.5 weeks to integrate for them, including their own OCS, which is their online charging system and policy management and so on. So much, much faster. That would have been at least a 9-month project. The POC, the trial would have been 6 to 9 months probably, and the actual going live would take anywhere between 9 to 12 months.
Another topic we talked about while preparing this episode was the SIM swapping. So could you elaborate on this?
Yeah, so one of the considerations, not just in the automotive space actually, but across the remote connected asset space and software-defined vehicle space, is this idea of vendor lock-in through the SIM.
Yeah.
So in the mobile space, and adopted actually in earlier generations of cars as well, as a standard called SGP02. Now this was partially successful in the industry. Some people have had good success. It's great centralized managed connectivity providers had great success. Some operators have, others haven't. But the goal there is to remove from, again, taking the view of an OEM here, is when you're procuring connectivity, you're looking at a life of a car over 5, 10, 15 years. You're not looking at it like you would your mobile phone, which is a year, or 2 years at max. So the ability to be able to install. These are soldered SIMs, Key-F-Nate SIMs in the car, and they're not removable and replaceable. So you need a way to update them to make sure that if you change your connectivity provider, you can. So the original standard SGP02 is still very much in the field, very much in use, and will remain in use for the generations that have adopted that. But there's a new standard, which is SGP32, which is a hybrid of a bit of the consumer standard, the IoT standard, and so on, which we don't need to go into in this session. But the SGP32 solution is being used now by OEMs to provide much more flexible swapping of not just the profile on the SIM, but how that's managed, something called the IOM, and a set of other components as well. But basically you can end up selecting any operator without the other operator having to actually agree. Whereas in SGP02, you needed to have an agreement or own the swapping solutions called the SMDP Plus yourself. So that gives the OEM now the opportunity to really swap, not at will, because they'll have contracts against X number of active subscribers over a period of time, but swap between vendors at particular, not necessarily align the contract period of the connectivity with the in-life requirement of the SDV itself. One of the key things in the automotive space is control of the connectivity at lots of different layers and the visibility around it, but I think control of what the connectivity does and where it goes is very important in this space. So our solution out of the box provides the ability to route things in certain ways based on the traffic type, what it's supposed to do, where it's supposed to go. Today, we use, everyone else uses APNs to determine that. So a device has to connect on 3 different APNs in order to have infotainment, telematics, and whatever, right? So for us, you can have all the same APN, and based on that traffic type and the configuration of it, we can just route things in different directions, block things, reroute them. We can provide local DNS. So it's about bringing the richest experience to the edge, as we would say at Stacuity. One of the things I think is pretty unique to us at the moment, so we've got 5G SA coming, right? 5G SA is still coming from a roaming perspective. There's networks in the world that have it on their own home network. But for us, we have a pre-5G SA solution as well as a 5G SA solution, but a pre-5G SA solution that still allows you to bring things to the edge. So you imagine we've got some AI in the vehicles now.
Yep.
And we have AI back at base, on-prem or in the cloud for operators and for the OEMs themselves. We are able to provide container-based execution of runtimes, whether that's actually AI or standard compute, on the edge. So you can have layers of AI, layers of compute. So that reduces your latency and allows things to be quicker for the SDV.
Really interesting. How would you describe how you guys fit into the automotive ecosystem so that everybody understands really clearly who you deal with and how you can interact with?
Sure. So if you put the OEM at the center and then work up. So you have the OEM, and then connected to them, or connecting them actually, is in fact the MNOs, MVNOs, and managed connectivity service providers.
Yeah.
So those guys have the relationships with the OEM. The OEM works directly with them and gets service from them. That might be local profiles, it might be roaming profiles. But the mobile network operators leverage us as a connectivity, as the core network and data layer, as this centralized platform to unify their connectivity experience for their customers. So we're an enablement layer.
Is it a fair statement to say that you are making the SIM smarter than they used to be?
Not so much the SIM, it's the actual connectivity which is smart. Because the SIM card, SIM cards are actually little computers. They do have a processor inside them, but they're often constrained by the device that they're in. And if that device is like a wearable with very low battery capacity, you can't put much intelligence, you can't work the SIM very hard, you can't put lots of intelligence in there because the battery will run down. So we're taking all that intelligence, putting it in the network, so it doesn't have to be on the device.
To conclude, it's the same island who brought 3G in 2001.
I wasn't here for that.
But it's the same island that now might change the way that we look at connectivity in the automotive.
We hope so.
That's really great. Thank you so much, John. It was a massive pleasure to talk to you.
Thank you.
And here we are concluding the most ambitious episode of this podcast yet. We went to the Isle of Man to learn that long before there was any technology, there was already a network. 600 people in Orange holding a 37-mile road together, passing each rider from one to the next at 180 miles an hour and never losing a single one. And it showed me that a small island, fewer than 100,000 people, can build technology that changes how the whole world thinks about connectivity. How a car reaches the internet, how cars talk to each other, how they talk to the road around them. Here, I met people who believed that you don't need to be part of a massive corporation to change the world of connectivity. Honestly, it's been an incredible week. I hope you enjoyed watching this episode as much as we enjoyed making it. Before I go, I would like to say thank you to the Isle of Man TT organization, to Laura and the Marshals, to Chris, the 3G pioneer, and to Mike, John, and the whole team at Stacuity for your warmth, for your time, and for taking me deeper into connectivity than I have ever been. You have pushed us to new limits. And thank you, Emily, for being with me since the beginning of this podcast a year ago, and for being behind the camera and your computer. Behind every dashboard, every ADAS feature, every line of code lies human stories. And those are the stories we are here to tell. So if this one stayed with you, subscribe to the Automotive Storytelling so that you don't miss the next one. Thank you for watching. See you next time. And if you want to know more about what they do, I would recommend you have a look at their website, stacuity.com/automotive. You will find a link in the description of this episode.